All right, so first of all, I want to start apologizing because this is a talk meant to be done in 3 hours. And I'm not going to make you stay here for 3 hours, I hope. So there's a lot of material to cover. I'm just going to skip a little bit through it and focus on what you may find the most interesting parts. I don't have any specific preference. So please stop me anytime, any point. Ask any question if you think it's a simple question, maybe you think it's a stupid question, ask it. Otherwise, there will be no answer, and there are no stupid questions. We'll learn from those. So please do ask any question. And all the presentation and the source code we're going to be looking at is already in the internet. So feel free to go now and grab it if you want to. The presentation is, you can see the URL on the screen. It's on the slide share. So if you look for Gnosis, N-O-S-S-Y-S, you can get the presentation. I'm just going to be following the presentation from that part. And this presentation is also meant to be a little bit interactive. So we're going to be looking at source code. We don't have a lot of time to be looking at source code in great detail, but anyway, all the source code is on GitHub. So you can go to GitHub and under 8K data, you can find this Java Postgres repository, which contains all the examples on the source code that we're going to be looking at. So feel free to go there, clone the repository, and open on your favorite IDE, whatever it is, or VI, or whatever. And so we can look at in real time at the source code. So let's get started. So this talk is about using Postgres in Java. Honestly, there are a few specific Postgres things, but this can also be quite general to other databases if run from Java. A little bit about myself. I'm not going to lose time with this because we have a lot of material to cover, but feel free to look at it. If you don't know me, Alvaro, or Alvaro, whatever you prefer. I work in Spain for a company called 8K Data, previously called Gnosis. And we'll do a lot of stuff in the database, Postgres world, and also the Java world, a little bit cloud computing too. And here are my coordinates, Twitter, LinkedIn, if you want to send me a note, ask a question, whatever. All right, so let's get this started. We have a lot, as I was saying, there's a lot of material to cover here. So we're going to talking about why Postgres in Java. And then I'm going to explain the methods of connecting to Postgres from Java. Some weird ideas here, maybe interesting for someone. Then I want to focus this a little bit on JDBC, because what I found is that there's a lot of material in the internet about JDBC, but most of it is not correct. Has errors, it's outdated, and very few people write the most simple JDBC code in the wrong way, especially because of following this. So I'm trying to give some advice, some best practices here, and it's going to be really simple. But anyway, examples are not usually correct. So this is one aim for this talk. And by the way, we'll see how the code may evolve or evolved in the past from Java 1.4 to Java 8. So we'll see how things get easier. And finally, I'll give some quick overview about some frameworks that I would recommend and why to use with Java to interface Postgres. Because doing code by hand is not very good, but using some ORMs is, in my opinion, not very good neither. So what's the answer? Which is the way of using the whole range of all the big functionality that Postgres has from Java. And that's usually not the answer of going through an ORM, again, my opinion. So, Postgres and Java. First question is, do they fit well? I mean, is this a nice couple? Many people don't think so. And it's usually a little bit strange, right, to talk a lot about Java in this kind of conference. C conference almost, right? But, there are some numbers that tell us that it's not good shape. Like, for example, you look at the traffic on the JDBC mailing list for Postgres, and it's very low traffic, like 2 messages per day average. PL Java, it's like stalled or almost dead. And then we have these cool languages, right? JavaScript, Python, Ruby, whatever. They're cool. They're fantastic. They're fast. So what's about Java in Postgres? Furthermore, and well, there are some people who would like to use Java, but they want an API which is not JDBC. A more direct API. They look for the database API in Java, and there's no such thing in Postgres. For good reasons, or not, but there's no such thing. And there's also a problem because many people have experienced Java connecting to Postgres through ORMs, like Hibernate, and they have experienced big problems, and so they think that Java and Postgres are both suck. However, the reality is that, well, Java is the enterprise language. Want it or not, it's the enterprise language. And this means a lot. Databases are used frequently in enterprise environments, right? So it's a good fit. Plus, in reality, and probably because of this, Java is probably the language most used to interface a Postgres database. So we need to pay attention to this. There's a good reason to use it and support well Java interfacing Postgres. Both technologies, needless to say, are very mature and reliable, so they're a nice couple in that sense. It's a winning combination. And, well, there are more options than the usual ones to connect to Postgres. We're going to see them. In terms of popularity, well, Java is a very popular language. It's all the time alternating between the first and second place in some popularity indexes. So, yeah, makes sense. And this is quite surprising. If you look at what the new tendencies in places like GitHub, right, where most people tend to think that these new cool languages are basically taking over the world, well, it happened some years ago, but no longer. You can see here that Java repository, Java content on GitHub is growing significantly. JavaScript too, right? But most other languages like Python or Ruby are indeed losing proportion with respect to other languages. So in other words, in summary, we need to pay attention to this. That's my opinion. And here are the numbers. So how to connect to Postgres from Java? JDBC, that's of course the usual answer. It's a standard, and it's also the de facto standard. So I would say 99 point a lot of the connections to Postgres from Java go through JDBC. However, it's not the only option. There are some other options, probably not recommended at all, but in some cases they make sense. We're going to look at them just right now. Just before talking about JDBC driver, I'd like to, that's a long topic. I'd like to iterate on this part. So we have the standard JDBC driver. It's well-known, well-developed, performs, well, Joe knows how it performs. And it's good. So it's probably the best alternative. And if you're in doubt, I would probably say go through this route. So use the standard JDBC driver, the one that's produced by the Postgres community. However, it's not the only option, as I was saying. There is, for example, an alternative driver. It's called the PG JDBC Next Generation. And it's a surprising piece of code, in my opinion. I like very much the idea behind this driver. It's not meant to go through all the compatibility stuff that the current driver is, which involves a lot of code and a lot of work, and that's really amazing. But it took a clean start and say, okay, we're not going to support this old stuff. It's only going to be for new stuff. Rather than writing everything on our own, we're going to use like frameworks that are already existing in Java. Like, for example, for all the network communication, it is using the native framework. Are any of you familiar with this framework? A little bit. So it's for you that those of you that don't know, this native framework is an amazing piece of code using very, very high throughput environments. Like, for example, Twitter is using it very extensively. It's a framework for synchronous event-driven network communications. It's really, really fast, easy to use, very mature. And so basically, why reinvent the wheel? I mean, network code is complex, and it's hard to make it perform well. So this driver is basically saying, I'm not going to do this. I'm relying on this framework. And so on several technologies which it's using. So it's a clean approach, modern approach, modular approach. And so far, it's in good shape. I wouldn't say it's, of course, the same level of quality and development as the let's say, standard driver. But it's a good option. It's been focused on, you know, that the Postgres wire protocol has like mainly two modes of operation, text mode and binary mode. The standard JDBC driver is mostly text mode, except for the copy operations. This driver is focusing on doing mostly everything in binary format. And it claims to have achieved significant performance gains on some specific circumstances. So I think this is promising. It's just this, another approach. So I would recommend you to have a look at it. It's BSD licensed too. Has anyone tried this driver? What is your opinion? Yeah. So it's something we need to pay attention to. I think it's quite interesting. What else? So I was saying that there's like several options of connecting to Postgres from Java. One is the standard JDBC driver. So this is still JDBC. The other one is using this alternate next generation driver, which is again JDBC. Is there anything outside JDBC we can use to connect to Java? The answer is yes. For example, we can execute an external process from Java, open command and run PSQL, and then connect via the standard input. Yeah, I know, this is not fairly standard, but it's surprisingly interesting for some use cases. Of course, it requires the local connection. I mean, running locally, well, you can run PSQL and then connect remotely, but then there's not a real point in doing so. But it is a point on doing something really efficient. We had to do that in my company because we did a project, some of you know about this, about trying to create 1 billion tables within a single database. And that required some kind of speed. And we tried this approach, which is to basically send commands via the standard input to PSQL. That was the fastest thing we could get to create tables fast. So there are some use cases for this. By the way, we were able to create like 12,000 tables per second. That was our goal. And we could have done this thing without reverting to this method, sending commands via PSQL, via the standard input. So how do we do this in Java? If we want to do this in Java, for whatever reason, the technique here is to use a class called process builder, which helps you fork an external process and connect the standard input, the standard output, the standard error output, and connect them to Java input or output streams. It's very easy. I have a demo here, but I'm going to skip it by now. If anyone's interested, please let me know. Otherwise, I'll switch over to some other topic. However, the demo, the source code is in the GitHub repository mentioned before, so you can go and have a look. It's very, very simple code. It has no dependencies, and it plain works. So this is one other method. The other method, it's a little bit funkier. Suppose that you want to do something that's not supported on the JDBC driver. And there are a couple of things that are not supported on the JDBC driver. And, but on the other side, that may be supported in the libpq library. So if you want to still use that functionality from Java, the only way around is wrapping the pq library to use it from Java. In other words, to create JNI bindings for the library from Java. Fortunately, there are some people who has done this before, and there's a library which it's called Swig, which is basically helping you more or less automatically create a binding from any C library to Java using JNI. So it's just basically running a script, over the source code of libpq, and you'll get a Java wrapper library for it. And then you can call methods and use underneath the PQ library to call whatever methods supported in the libpq library from Java. So again, this is another way of doing it, and again, kind of works. Some special cases for doing this. Well, for example, the use case that happened here was about so there are two main use cases I found this may be interesting. One is working with complex data structures like arrays of custom data types, for example. They're tough to do in JDBC. You can do that, but they're tough. While it's easier if you use PQ directly. Because basically, serialization of these data structures in JDBC, it ends up converting them to a text representation internally. And so if you want to parse that back, and you're doing fancy things, you need to hack the basically toString method of your data to match what is expected to be under that text representation. It's a little bit fragile. The other use case I've seen of doing this is connecting to when interfacing via PG pool, which has some limitations too, and there were no support for that kind of things that you wanted to do from Java when interfacing via PG pool. I don't remember exactly the use case, but it was related to that. And if you look at this URL in the bottom of the page, there you can find this use case perfectly explained. Another option, another interesting way of doing this is about using the copy mode. Copy mode is supported in JDBC, and it works quite well. I'm going to talk about that. Joe knows. But still faster in PQ by, can you say general figure? It's like margin, right? Yeah. But still, if you need some extra performance edge, you can do that. And finally, and this is not per se a method of doing it, it's just an encouragement, that you can, of course, interface directly if you dare to speak the front-end, back-end protocol on your own. I mean, it's just sending and receiving bytes over the network, right? If you happen to write the correct ones, you may talk to Postgres directly. But this is not a silly thing to do. I think there's room for doing like general Java library to speak the protocol. There are a lot of things that can be done at the middleware layer by speaking the protocol. So I don't know of any direct implementation other than the one contained within both JDBC drivers, but nothing I don't think that would be quite interesting to do. All right, so these are all the alternative methods that we can use to connect to Postgres other than JDBC. So let's do a quick recap of what JDBC, the standard, the main driver is, and then we'll switch to see some real code. So we're doing well. So JDBC stands for database, Java Database Connectivity, has been here for a long, long time. Which is good and bad. Current version supports is version 4.2 of the JDBC standard, which was released together with Java 8. It's the connection itself is database independent. It has like the database dependent part, driver part, and API implementation part. There are supposedly 4 types of JDBC drivers. The type 1 is basically an ODBC bridge. The type 2 would be similar to what I was saying before about the wrapping the PQ library. So basically interfacing via native methods, but from Java, like GNI. The type 3, which has been used in several products I've seen in the general database space, it's basically interfacing via middleware layer. And the type 4, which is the current driver, it's a native implementation of the protocol. There's also when we talk about the different JDBC drivers that we can find, there are a couple of them, like the standard JDBC driver, the alternative JDBC driver I was mentioning before, the Enterprise DB JDBC driver for doing specific Enterprise DB Postgres plus advanced server things. And there's also the Progress, I don't know if you know this company and this driver, Type 5 JDBC driver. Does anyone know what's a Type 5 JDBC driver? Have you heard about this driver before? Progress, Data Direct, Type 5 driver. OK, so I don't know what's Type 5 driver neither. I've been looking and studying in detail their documentation, their facts, and I still don't get it. It's basically a better, in so many sense, driver. But from an architectural perspective, I see no difference. But it's funny anyway. And there's a driver for Postgres. I don't know if anyone has been using it. Let me know if you have done it. But it's still a good option. Haven't tested it. But suppose it's Type 5, which means greater and better. Huh?
And it goes to 11.
All right. Some basics about the JDBC driver. It's a native implementation of the front-end, back-end protocol. You can download it from jdbc.postgresql.org. However, I would recommend you to use Maven or any other tool for managing the dependencies in Java projects rather than directly downloading the driver. It supports most of the usual authentication methods and uses UTF-8 for database connection, so kind of represents the more general stuff you need to do. Supports SSL. There are some caveats there I'll be commenting right now. It's basically JDBC standard, but it supports some extensions specifically for Postgres, this driver, like, for example, the copy mode, which is very interesting, which, by the way, is something that very few people use. You know the performance difference, right? And it's really, really a significant difference for some use cases. So it's not a standard, so it's not all the time OK to break standards, but it may pay off. Basically, when you connect via JDBC, you specify connection URL, which looks like this, JDBC PostgreSQL. And then you pass some parameters, like the usual database connection parameters. There are several versions. If you go to the download page of the driver, you'll find several versions depending on which version of the JVM you're targeting. I would always recommend go for the Java 8, Java 7 version. At least Java 6, where you have JDBC 4, which is the most major version of the JDBC driver version, and it has a lot of advantages over previous versions. And as I was saying, it supports a very broad number of Postgres versions down to 8.2, and I guess, if I remember correctly, several earlier versions too under some circumstances, at least with protocol version 2. All right, so let's look at some code. So I've been talking a lot. But by the way, who's familiar here with Java code? Or, all right, so the rest of you are unfamiliar with Java code? All right. I don't have time enough to go line by line because there's a lot of code. But please, as I was saying, anything as silly as it may sound, it may be sillier not to ask it. Because maybe it's not. Maybe it's a smart question. So here's what you will probably find if you go to any, is this OK? You can read the code? All right. So if you look for JDBC and Java in the internet, you'll probably get to a page that has code like this. First of all, you do class for name, and you specify the fully qualified name of the Java JDBC driver. This loads JDBC driver in memory, the class loader, so you can access this code. Then you specify the connection. So you get a connection object. To get a connection object, you call driver manager.getConnection, and you construct the JDBC URL I was just mentioning before. So it's JDBC, colon PostgreSQL, colon, and then some parameters like the host, the port, and the name, user, and password. I'm using external class here. Sorry. These are the parameters. This password is not secret. Don't worry about it. And so we can look at this, and all right. And if we go back to where we were, yes, here we are. So we construct the URL, and finally we use the connection to do things. Like, for example, we're accessing some metadata, which is basically the information from the database. So very simple code, right? However, please follow the comment here and don't use this code for production. It has some errors, some problems. Can you spot any? There? No? Connection can be null. Oh, that's what you're saying? Okay, yes. Goes a little bit deeper than that. Any other idea? Exactly. You don't have to load the driver. This is very old code. This works for Java 5. I mean, it's not wrong. You can do it. But if you're using Java 6 onwards and JDBC 4, you don't need to explicitly load the driver. However, surprisingly, really, 99% of the tutorials on the internet still do this. JDBC, Postgres JDBC documentation still do this. I think that should be fixed. All right. Yeah, I know it's my responsibility to send the patch too. Don't take my words. So we have this not a problem, but something that we can improve on, and that the connection, we're not checking whether the connection is null. Okay, we can add a test. I don't have time here to do it live. I would like to do it. But yeah, we're not checking whether the connection is null. So we can get here a null pointer exception if the connection happens to be null. Any other thing? Never release the connection. All right. And there's a last error here. So we have basically 4 lines of code, 3 lines of code, basically, and already 3 errors. The last error is related to checking nullness. It's, or closing the connection, by that matter, is that we're not checking the exceptions. Yeah, if the connection is null, it means that we can connect, but then the code will throw an exception. There's no exception checking code here. Indeed, we can see here that the method has like throws class not found exceptions equal exception. It's basically wherever happens, blow up and stop the program. And this is not good. However, as I was saying, this is what you will probably find in the internet. Most examples, 90-something% of the examples you'll find on the internet tutorials will have code like this. This is very bad. Don't do this. So we're going to try to fix this. So let's switch to the next example file. So this is I have like here like an iterative approach. So we're going to construct small programs step by step and fixing the errors in each step. So this was the first one. Don't do this. Let's look at the next one. How we can fix this code to at least watch for the exceptions, make code more safe. So, well, we already know that we don't need to load the class, but still, if you want to do it, for example, you're using Java 5, not Java 6, you still need to do this. So we're going to keep this code for a moment. However, we need to check for also exceptions. What if the driver is not present? Well, if the driver is not present, it's OK to fail. However, it's nicer to catch the exception than take appropriate actions to inform the user or whatever. Then, when connecting to the database, we have to wrap the code on a try, basically catch block, because basically all the operations on the JDBC package throw a SQL exception. So we need to check for that. So here we instantiate the connection as we were doing before, then if this line of code gets executed, this is an assertion, we're guaranteed that the connection is not null. So now we don't need to check for null pointer exceptions. And on the try catch, the catch part of the block, we catch the exception and do whatever. Like, for example, in this case, throw an error connecting to the database. And then if we look at internal operations, we were connecting to the database and getting some metadata. But that operation can also throw a SQL exception. So we need to catch that exception too. And this situation may be way different from the connection exception. The connection exception is like may reveal a problem on the network, for example, whereas getting the metadata or running a query may be a problem of your code or the parameter your user is passing and that you have SQL injection or whatever. So probably the actions you need to take are quite different in both cases. So it makes sense to catch these two same exception, technically, but in different places and probably take different actions. So one is here, the other one is here. And as someone else pointed out, we need to close the connection. So we need to call connection close. However, closing the connection may also throw a SQL exception. So you may treat that differently or not. In this case, I'm just dropping that option here in the outer SQL exception. And that's why the error message I'm throwing is error connecting or disconnecting from the database. Because this operation may also throw a SQL exception. We're using here finally to guarantee that the connection is closed. Finally guarantees that that code is going to be run regardless of what happens in the program. So this is more or less correct code. And as you can see, it's not very nice, right? So if you put this in a tutorial about how easy it is to use Java from Postgres, I don't know if people will be running out. But it's correct. So that's the way to go, at least with Java 5. So we're going to look at next example. Well, this one is trivial variation. It's just basically if you're using Java 6 with JDBC 4 driver, you don't need to load the driver. The rest of the code is the same. So just skip the first part of the code. Now it looks a little bit better, but it's still very convoluted with checking the exceptions. So let's jump to a next example. Please let me know if I'm going a little bit fast. I'm trying to, because I want to cover a lot of material. But anyway, you have the source code on GitHub too. So far, that code was already convoluted, but at least safe. But we were doing nothing. We were just connecting to the database and getting the version out of the database. Probably we need to make a query sometimes. So let's do a query. So here I have a query. It's a string. And then I basically now try to query the database. So in order to query the database, first of all, you need to create a statement object. You create the statement from the connection, and then you can execute the query. However, both methods, create the statement and execute query, can also throw a SQL exception. So we also need to handle this. So we have the first basically try catch block for the connection. Then we need to create the statement and wrap that code inside another try catch block, right? Because that may fail. If there's a SQL exception, I just print or do whatever. And then within the finally block, I need to close down resources. I have to, first of all, check whether the statement is null, if the statement was not correctly created, and then close it. By the way, closing the statement may also throw a SQL exception. And also close the connection, which may also throw a SQL exception. Complex, right? Yes, it's not very nice. And so processing the query, this is a simple query with some aggregate functions over a test database, which is also included in the source code. And then you, when you execute the query, you get a result set, and you can iterate the result set with code like this, which also throws a SQL exception if it encounters an error. And you can get column 1 as a string, column 2 as a string, and column 3 as a double. And this works. We can run this code. It's not really interesting, but we can check that it works. Yeah. So we can see some data here. So this is kind of working. So this basically should be probably the right tutorial code to show in the internet for people trying to learn JDBC from Java. Because I was saying this is not really nice and has some other problems too. So we need to go a little bit farther than this. Here we have an example where, well, I was going to ask this before. Have you realized any problem with this code so far? Any reason why this code may not be really good? I'm giving a hint there. Well, basically, this query is constructed by hand. And also the parameters for the query, like this number, well, in this case, it's hard-coded. But supposedly, this may come from a method. And then you can do string concatenation and concatenate the parameter there, and then execute the query. But I'm sure we all know the problems that come from doing that, right? SQL injection. So we can execute a query directly. That's what we were doing. But we better use a method for passing parameters to the query in a safe way, which is using prepared statements. So let's look at the next example, which is doing a query with, can you see the code like this? Is it OK font size? No, it's presentation mode. OK. So this next example is mostly the same as the previous one. However, we're using question mark as a placeholder for parameters. And rather than creating a statement, regular statement, we're creating a prepared statement. And prepared statement, you can set the parameters in a safe way, like this. So this is parameter number, and then the value. You specify set int, set double, set boolean, whatever. And this is a safer way of doing that. There is still the option of executing queries if you really need to create dynamic queries. So that's the only reason for using a statement. Otherwise, use a prepared statement. Some people say, and we were discussing that yesterday, that prepared statements may be slower because they need to have the parse bind phase too. But it's not true for JDBC drivers. There's a threshold that you may configure up to which point the prepared statement in Java turns into a prepared statement server-side. So by default, the first 5 invocations do not create a prepared statement server-side. Above that threshold, it will create a prepared statement if you're executing the same query. The rest of the code is more or less the same, so easy stuff. Yeah. Can you repeat that? All right. So prepared statements allow basically you to set parameters in a safe way. OK. Prepared statements, in the Postgres protocol, you may execute a query directly, or you may create a server-side prepared statement. Oh, OK. Now, by default, the prepared statement, the Java prepared statement object does not create a server-side prepared statement. Only when you execute that same prepared statement more than n number of times, it creates a server-side prepared statement. And by default, that number is 5. Yes? Yeah. OK, glad that you have some takeaway from this talk. And you can configure that on the JDBC URL or calling a set parameter method in the connection. And you can set the prepared statement threshold parameter. Good. What else? What if we now want to keep on evolving this example, which should be the canonical example of how to connect to Postgres from JDBC and make it a little bit better? Because I'm still not happy with it. Now we have prepared statements, we have correct exception checking, but there are no really good, in my opinion, best practices here. I'm going to go through these best practices right now real quick because I want to touch all the topics too. But for example, the connection parameters are hard-coded. They're an external class, but it's called hard-coded dbconfig. We saw this class before, where the username, password, everything is there. This is, of course, not a good thing to do, which most examples in the internet will do, but not that you should do. So for example, you can get the connection parameters from an external source, be it network, be it JNTI in Java, or whatever, but at least use an external file, like a properties file. So this next example is just the same as before, but just using loading the properties from the connection properties from a properties file. You can look at the source code. I'm going to just go through it right now. So this is a little bit best practice. Don't hard code the connection parameters, which most tutorials do. Now let's jump to Java 7. Is there any advantage of using this code with Java 7? Open question. Go ahead. All right. So basically, with Java 7, there's try with resources. And the try with resources is an automatic way of managing things that can be considered like resources. Sometimes it's stuff that you can basically open and close. And rather than doing all this try, catch, finally stuff that we've been doing, Java 7 makes it easier and absolutely safer to do it because Java 7 will make sure that they close the resources if you open with this try with resources. So this now finally makes the code easier to read. So a try with resources is a try where the resource that you want to instantiate is between the parentheses. And so, for example, here we are asking for the connection to be automatically managed by Java, the opening and closing. And I just basically, this is the same code as we had before to open the connection, just calling the parameters from the properties file. And that's it. I still need to use the catch SQL exception because that may be thrown, but I don't need to do the finally stuff. So the code now looks simpler. The same thing with the prepared statement. I just open and close the prepared statement within a try with resources block, so I don't need to explicitly close it and check whether the statement was null or not null, and then checking the statement and then closing the connection. Java 7 takes care of all this. So I just open the connection, open the prepared statement, and execute the query as we were doing before. I just catch the SQL exception in general terms to check for errors. Now, this code is safer and easier to read. So that's better than we had before. All right. Looking at the next examples, we have here some code about a next best practice, but this is quite usual, so I'm just going to skip it. It's about basically creating a class model, so doing MVC, not MVCC, right? Model view controller, and splitting my code into a model and a controller and a view. Well, there's no view here because I'm just printing the information, but at least model and controller. Model is the object that only contains the information. The controller connects to the database, gets the information, put it on the model, and then I can use the model, the class, with the data. I can move it around. So this is basically the code that we have here. And it's iterated in 2 steps. One, which I create the model, and the model basically connects, receives a result set and fills in all the data to itself. And another one with a specific controller, usually called DAO, Data Access Object, which operates over it to fill the data. Just best practice, feel free to look at the source code. But I want to jump at the last example, which is how to do this in Java 8. So we've seen the advantages of using Java 6, which is basically we need to do the class loading manually. the advantages of using Java 7, which is basically we can handle the automatic closing of the objects, resources we were using, with try with resources, and then Java 8. With Java 8, we can use lambdas to follow a more stream-oriented way of processing data. So we can just connect to the database, grab the data, grab that into a stream, and then do stream processing. And that's really neat. So it's something really recommended. Here's just a very simple example where the code looks really nice compared to all the stuff that we've been doing before. If you look, for example, at the main method, so it's just the presentation mode. This code already performs a little bit more fancy stuff. And we basically here, the main method results in a very easy method because we just gather the connection as we were doing before, instantiate DAO, which is the way of processing the connection and getting the information, and then call higher-level methods like get countries languages of 95. So no hard coding or of SQL parameters. The SQL code is hidden beneath this method, like in the DAO. We're going to just have a look at it. And then by calling this method, I get a list of objects of type countries language, which is the information I'm waiting to get from the database. And then I just iterate very easy with a stream method from Java 8, which is for each. It's very easy, guessable what it does. This also enables to do or to show another best practice with Java 8, which is to use inversion of control. Are you familiar with IOC, inversion of control? Right. So basically, inversion of control is a technique of asking other objects that know really what to do with stuff to do it on behalf of me, or vice versa. So with inversion of control, rather than having to know how's the structure of my object, so I can set the data I get from the database into the object, which basically means that I have to know what the structure of the object is. I give the object the result and ask the object to fill itself. This is where the inversion of control happens, and makes the code less intermingled and easier to refactor. It's critical in broader development techniques. So in order to do this, not getting into a lot of detail, but basically we create an interface, which is in this case called query processor. This query processor has a single method process, which receives a result set and throws a SQL exception. And now what I'll do is that my objects will implement this interface and will be able to process the data from the result set and fill themselves. So external objects don't need to have the logic of what to do inside. Sorry, 2 minutes? Wow, all right. Okay, okay. That's okay. So then I'm going to wrap up a little bit. Well, this 10-step example is already explained, so I'm happy with that. And again, you can look at the source code. Some final notes. If you look at the presentation, there's some best practices and common pitfalls when using JDBC that people experience like very frequently, like for example, when connecting with SSL. By default, the JDBC driver will not connect if the driver is not correctly signed by a CA. So people using self-signed certificates experience problems. Here's how to circumvent them, yet not recommended to circumvent them. And some parameters for connecting some extra parameters for configuring the JDBC. Finally, what I'd like to say is about the last part of the topic I had in this agenda, which is frameworks, right? So this JDBC code that we've been seeing right now, it's okay, but it's a little bit manual. You need to do some repetitive tasks. So that's what supposedly ORMs are made for. However, in my opinion, an ORM is a very difficult problem that has never achieved to solve the real difference between a relational world and an object world. And the results that they usually give are very poor. And I've seen no single installation. I mean, in professional speaking, every single time I've seen an ORM being used, there has been performance problems and some other types of problems. So my recommendation is don't use ORMs. However, my recommendation is needed to do this everything all by hand, because that's error prone too. Fortunately, there are at least a couple of frameworks, not ORMs, but frameworks that I know of, that help you with this task of doing all the manual code, while at the same time allow you to explode all the potential that Postgres has and let you do very advanced queries, which is basically one of the reasons of using Postgres for most people. So these frameworks are called MyBatis and Jook, J-O-O-Q. I really recommend you to look at both of them, especially the last one, Jook. So I like it very much. There, in the source code published in this repository, there are also some examples of doing this same code with both frameworks, with MyBatis and Jook. And as I was saying, it's really, really recommend. There are also some notes and some reasons on the presentation I encourage you to look at why these are really good. But basically, Jook is about specifying the query in Java language, but in a way that looks so similar to what would you be doing in SQL, but it's at the same time type safe. So it's actually really good. I'm just going to close this by showing this on the screen. Well, I don't know if we have time for questions. I guess not. But we're just going to finish. I'm just going to put this on the screen so you can have a look at it. And that's going to be it, basically. So this is how you would do a query with Jook. And this is type safe code. All right, so sorry that we don't have time for questions, but if you have any, please come to me. No problem.